Okay, so the IL analysis. So why it is important? Because actually the relationship that we have already derived, which is the V out is equal to duty cycle multiplied with V input. This one is derived based on the assumption that the current of the IL is continuous or in CCM mode, continuous conduction mode, which is like this. As we can see, the current is always continuous. Okay? So if the current is not continuous or discontinuous mode, DCM, so this relationship is not valid. The relationship between V out and V input that we have already obtained is no longer valid when the current is DCM. So we need to ensure that the current is always in CCM. So that is why the IL analysis is very important. Right now we can see that we have, for the current of the IL, we have I max and also I minimum. So what is I max? So this is the equation of I max, which is the IL average. Tak nampak this one. IL average plus delta IL over 2. And I minimum is IL average minus delta IL over 2. So what is IL average here? This one is actually equals to I out. Okay. So IL average is equals to I out, which is V out over resistor. So in order to maintain CCM, so you need to ensure that I min is always larger than 0. For CCM. Okay, so need to always make sure that I minimum is always greater than 0. Okay, and your I out is equals to IL average. Okay, IL average is a DC current. Okay, you tak perlu, you don't need to actually memorize these equations lah. You don't need to memorize. As you can see, very long. I prefer not to memorize these equations. What you need to do is actually to know what is I max. So I max is IL average plus delta IL over 2, and I min is delta IL minus delta IL over 2. That is the only thing that you need to know. So how to know this one is actually, if I can share the, sebenarnya for this chapter, I prefer to write down dekat whiteboard. Tapi since we don't have, we need to tackle 2 students, so I need to use the virtual whiteboard lah. So this one, kenapa tak ada sini? Tak ada juga. Oh, pening kepala ni. Sebab saya ada share ni. So ni pun I need to. Baru. Okay. Baru faham. Lepas tu nak buat apa ni? Okay, I want to share this. Tapi kenapa tak keluar? Okay. No, student tak nampak pula Student online tak nampak pula. Can you, for online student, can you see my whiteboard?
Doctor, we can see it. It's a
The
circuit.
whiteboard. Okay, thank you. Microsoft Whiteboard. Lepas tu macam mana pula saya nak tengok ni? Okay. Microsoft Whiteboard ni, okay. So, this one, kalau saya conteng balik oh, nak kena tengok lah. Kasi saya tak dapat tengok. Ataupun, nak kena tukar setting pula lagi. Okay. Payahlah. Sorry So, I think tak boleh lah kot. Just share kat sini je lah. Okay. So, actually, if you see this one, how can actually IMAX? So, IMAX. So, IMAX is here. So, this one is your IMAX, right? And this one, apa dia? IMAX and IMIN, between IMAX and IMIN is delta IL. Okay, between IMAX and IMIN is delta IL. So, meaning that your delta IL is actually IMAX minus IMIN. Okay, and at the center here is your IL average, which is in these 4 buck converters, your IL average is actually your I out. What is your I out? Your I out is V out over R. Okay. So, since we already know that this one is delta IL, so meaning that from here to here is delta IL over 2. From here to here is also delta IL over 2. Right? This one at the center is your IL average. Center. Okay, so that's why from here we can know that your IL max is IL average plus this one, delta IL over 2. And your I min is IL average minus delta IL over 2. That is the only thing that you need to know, how to derive Imax and also I min and also IL average. There are 3 equations that you need to know to analyze this IL. Okay, this one you don't need to remember lah. Okay, you need to know this one. Imax, what is Imax and what is I min and what is your IL average. Okay, tak apa, nanti in example I will show you how can we solve that by not memorizing the equations. But you need to fully understand lah how the circuit operate. From that, then you can actually know in logic boleh dapat. Okay. So and then from that, what we need to do is actually to make sure that your I min must be always equal to or larger than 0. Okay, and from that by solving that equation of I min, we will see that actually the values of I min is much related or actually affected by the values of the inductors. So you need to make sure that your inductor must larger than your L minimum. So this L minimum is the smallest inductor. Okay, so you need to ensure that your L is larger than L minimum. Because these values will give you L minimum here, will give you the value of when will give you the minimum current values. Current zero. Current I mean is zero. Okay. When you set I mean is equal to zero, okay, you will determine this inductor, which is will give you the values of L minimum. Okay, to ensure CCM, you need to always, your L actual must always larger than your L minimum. Kena make sure that. Okay. You set how to get L minimum. You set I mean is equal to zero. Okay. You set I mean is equal to zero like this. You set I mean is equal to zero. Then from there you can compute your this inductor, which is this one. This inductor is your will give you L minimum. Okay. After you got the L minimum, so you can choose your L larger lah, usually larger than L minimum lah. Okay. Okay. So we have finished on the IL. So next we go for the next analysis, which is the output voltage ripple. Actually, since this is a DC-DC converters, meaning that your input is a DC voltage and your output is also a DC voltage, right? But since this involves switching on and off, actually if this one is your V out, should be like this, right? Straight line, DC constant. But if you zoom, this one is actually not a straight line. It's actually just get some ripple, minimum like this. So we have a ripple voltage. So this ripple voltage is a high frequency ripple voltage. So but it will affect in terms of the power quality of the DC system. So we need to ensure that this ripple is a minimum as possible. And this ripple is related to the values of the capacitor. Okay. Usually if the capacitor value is large, your ripple will be very, very small. But when your capacitor is very large, your system will be very, very, very heavy. Okay. So to optimize the system, so meaning that kalau you tahu capacitor tu boleh ke tempat kecil, kenapa you nak letak capacitor besar, right? So that's why we need to do some calculation to know what exactly the size of the capacitor to obtain the required ripple. Okay. So first of all, what you need to do is to know what is the current waveform of the capacitor, IC. We know that from here, IL is equals to IC plus IR, right? From here. From this circuit. IL, and then it divide into IC and also IR. Okay? And we already know that for the inductor current is like this. You have positive RAM, negative RAM, and again positive RAM, negative RAM. Okay? And we know that IR is a constant, right? Is a DC current, right? So meaning that IC is IL minus IR, okay? So that's why you have IC of waveform like this. Tak nampak bawah. You sebenarnya IL ni you minus dengan IR. IR ni is actually a V out over R, right? A constant. So you just minus, so you will have this current ripple. You have You have macam ni lah. So that is your IC. Nampak? Tak nampak? Susah tu lah. Kenapalah bawah sangat Okay, that is your IC, okay? Sorry for that, because I cannot, tak boleh nak tinggikan lagi. So that is your IC. Okay. Boleh Kena buat something ni. Mungkin projektor tu kena dongakkan sikit. Siapa yang tinggi kat sini? Semua budak-budak lelaki boleh berdiri tak? Semua tiba-tiba semua jadi rendah Okay, from that current IC that we have obtained, so itulah nampak tak nampak ni. So we need to compute the area of this triangle here. Okay, this one lah IC This one IC. We need actually the area under this current IC is actually the charge, the amount of charge inside the capacitor. Okay. So we use a triangular formula, which is 1/2 multiplied with the height multiplied with the base. So right now your height is delta IL/2. Okay, sorry, this one is delta IL/2. Your height. And your base is half period, which is T/2. Okay, so that's why by using this triangular formula, so 1/2 multiply with the base, multiply with the height, so we will obtain this formula. But as usual, you can see when you rewrite this again and again, so you will come out with a very complicated equations lah, right? But usually I will not prefer you to actually to know these equations. I think it's actually enough for you to know this equation only, because it is enough to solve the problem. You know the period, you know the delta IL, then it's okay. Okay, you don't need to know this formula, this one also. Okay, oh ada tertukar atau pindah ni. Okay, sorry, ada tertinggal ni. Okay. Okay, so right now, oh macam ada tertinggal Okay, this one ada kat sini. Okay. Okay, this one is very important, this one. The amount of charge inside of the capacitor is equals to the value of the capacitance multiply with the voltage across the capacitor. So right now, the voltage across the capacitor is V out. Right? So that's why we have Q is equal to C multiplied with V out. Any change of the charge, which is delta, is actually result from the change of the V out. Because the capacitor is fixed. The value of the capacitor is fixed, right? You didn't change the capacitor. So anything that you have a change of column, the charge column, is actually because of the change of the V out. So that's why delta Q is equal to C multiply with delta V out. Okay? So this delta V out is actually ripple output voltage. That is the ripple voltage. Okay, yang saya ceritakan tadi, this one is your V out, right? Tapi if you zoom, dia actually has some high frequency ripple. That is your delta V out. Okay. So delta V out, so from this equation is actually equals to Q over C. Okay. So right now capacitor value is okay. But right now, what is the Q? The charge. So how can we know the equation of the charge? So the equation of the charge is actually you can derive from the area under IC. This one, the triangular area that we have already know. Okay, triangular. So the next slide is actually the equation how to calculate the charge, which is by using the triangular formula. 1/2 multiply with the height multiply with the base. Tak nampak? Okay. So if you obtain this, then you can, and then you just substitute delta Q into this formula, then you can obtain your V out or anything capacitor. In this case, you don't need to memorize this one. What you need to do is actually to memorize this equation. This one very important because this one is the fundamental equation that relate the charge and the capacitor and also the voltage across the capacitor. And to know what is the Q equation, you relate with the triangular formula. Okay, from that, you will obtain what is the suitable value of capacitance to obtain the ripple voltage that you want. Understand? Tengah hari ni memang I can expect that you 100%. 30% pun okay. Because if I tell you, I have an experience where one of the professor in UTM, so he invite one lecturer to actually give a talk during his class. Okay, 15 minutes, he fell asleep. So kita faham. So profesor pun boleh tidur. So macam mana lagi student? But you are the one that will sit down for the exam kan? The professor tu dia tidur lah. Tak ada masalah dia. Okay? So if you don't understand this, then you can just ask me if you don't understand. Okay? So if you macam delay, yeah, you don't understand but you kata very shy or delayed all the problems, then I think you will be in a very big problems lah. So if you are not understand, so please come. Yeah, you can just personally WhatsApp me and so on. Okay, let's do some example. We have example 1, we have example 2. This example 2 is a design. So your final exam will be like this. So you are designing a buck converters or boost converters. So you need to actually calculate all the elements. For example, the value of the inductor, capacitor, switching frequency, and so on. The rating of the switch. Okay. Because for the final exam, our question for the DC-DC converter is more on design. So you need to know the ratings and so on that's suitable for the circuit. Okay, you go first for the basic example first. Example 1, which is a very basic. You all have been given all the values. So in this example, I will demonstrate how to obtain these 3 questions without having to actually memorize all the equations. The output voltage is very straightforward lah. It's very straightforward. Maximum and minimum also. Yes. In the same slide, in the notes. Yeah. Okay. The output voltage. Very straightforward. But this one, I think you need to memorize lah. This one, very straightforward. V out is equals to D V input. Very simple. Ini boleh lah, you nak memorize. Kalau ni tak memorize, I think you are in big problem lah. Okay. So your V out, so your duty cycle is been given. Duty cycle is a ratio, It's a ratio. There is no units. Because D is a T on over T. Just a ratio. So 0.4 multiplied with V input, which is been given 50 volt. So 0.4 multiplied with 50. Berapa 20 volt lah. Okay, so this one, 20 volts. Okay. B, the maximum and minimum inductor current. So you need to know the basic equations lah. So for I max is IL average plus delta. Oh sorry, ni tak nampak So I think so kat sini. Ni tak payah tengok, you tak perlu tengok, you don't need to look at the equations lah. IL plus delta IL over 2. Itu saja. Okay? So we know that IL, what is IL? Is I out, right? Which is V out over R. So right now V out is we have already obtained, which is 20 volts. 20 over, the load is 20 ohm. So this one is 1 amperes. Okay? Right now, delta IL. So how to obtain delta IL? We know that delta IL, this one is your, this one, delta IL, which is I max minus I min, right? So, but you need to know the equation. What is, because from that, you don't know how to solve that. So what is delta IL? So mana tu? Delta IL, you have two delta IL. Which one? Delta IL during on and delta IL during off. Actually, delta IL, the modulus of delta IL, I on is equals to, tukar tu susah ni. Dia punya slide dia tak cukup panjang. Kalau ada 3 monitor tak cukup ni. Delta IL on must equals to delta IL off. Right? Because we know that delta IL on plus delta IL off is 0, right? Okay. So you need to know that delta IL on is equals to delta IL off. Modulus. Modulus. Meaning that we ignore the sign. Okay. So what is delta IL on? Ini kau memang kena tengok. You need to know, even though you didn't memorize, you can actually derive from the circuit. Yes. It's actually okay. So how I give you tips on how to derive delta IL during on. But first, what you need to do is to know the circuits lah. To memorize the circuit. So banyak condition pula ni nak kan. Buck converter, you need to memorize the circuit. This is buck converters. You need to know the ni je. The location, the switch, the diode, and the inductor. Because boost nanti, for boost converters, the location for the supply, the capacitor is same. The only location that will actually change is the location of the diode, inductor, and the switch. So for the buck converter, you need to memorize the location, the diode, the switch, diode, inductor, like this. Okay, so when the switch is on, what happened to the circuit? Itulah. Tapi kalau you tahu, so senang je. So when the switch is on, what is VL? VL is VS minus Vout. Kan? Okay, from that, then you are good. You know that VL is VS minus Vout. Then you should know that this VL is L didt, right? Okay, so from that, you dah tahulah. So maknanya, you change this one, delta IL over delta T is equals to VS minus Vout over L. Dah, tu je. And we know that delta T here is, during on is, apa dia? T on kan? What is T on? dt. Right? So, you change there, maknanya kat sini, yang ni during on, so multiply dt. That's all. This one. Kan? And then pergi balik, you go back to the IL, yang IL max. You go back, IL max is IL average plus delta IL over 2. So right now, delta IL, no matter you want to use, it's up to you. You want to use delta IL on or you want to use delta IL off, it's up to you. Because delta IL is same. Okay, for this example, I use delta IL on. Okay? Oh, yeah. Yes. Kenapa tak bagi L? Why didn't give L? So right now, your I out apa dia? V out apa dia? Kan? V out is I out multiply V out. Betul? Kenapa tak bagi resistor? Kenapa tak bagi induktor? Mana? Mana? Oh. Oh, belum. Tak. Okay. This one, I max. This one, I max is, itulah. Actually, apa dia? IL max. Inductor. Maximum inductor current. So right now, betul lah kita buat ni. This is the maximum inductor current. We have inductor current, dia RAM kan? Minimum to maximum kan? So right now, what we do is actually to get the values of maximum IL. Right? Faham tak? Sekarang, the values of the IL, so right now, IL from this equation, from here, I max is IL average. That's why V out over R tadi. Sebab dalam equation dia memang IL average. Okay? Ni, saya tak apa. Tukar sini. Ni. I max is IL average. Faham Okay. Sebenarnya belum tamat lagi tadi. So sekarang you calculate delta IL on VS minus V out dt. Ataupun panjang sangat. This one is very long. Delta IL ni panjang kan? You tak kan? So why don't we use delta IL off? Boleh juga, delta IL off. It's actually very simple. V out over L, 1 minus D T, right? So can you compute both delta IL on and delta IL off? You should get the same answer. Delta IL on dulu, berapa? Vs minus V out, 50 minus 20 over inductor 400 microhenry multiply with dt. Sorry? The same? What is the value? 0. Dapat. Okay. 0.03. And delta IL off? You should get the same answer. 0.03 also. You should get. Same. Boleh tak? Confirm kan? Can someone confirm? Delta IL on 0.03. If you use delta IL off, you should get the same 0.03 also. Modulus modulus. Kita ignore the sign. Dapat tak? Delta IL off. 1.5. Oh. 1.5. Your friend got 1.5. Can you 1.5? You need to double check. So this one should get 1.5 also. Boleh confirm tak? Delta IL off. I don't have the answer. Modulus So you should get the same 1.5. Okay. So confirm that whether you are using delta IL on or delta IL off for that equation to get your max. So it doesn't matter. You can use both. Okay. So right now 1.5. So your IL average that you have obtained earlier is 1 ampere, right? And delta IL over 2. So right now your delta IL is 1.5 over 2. So you should get 1.5 over 2 lah. So this one berapa? 0.75. 1.75 amperes. Kan? And for I mean, so I mean is IL average minus delta IL over 2. So IL average you have already obtained 1 amperes minus 1.5 over 2. So berapa? 0.35. 25 25. 0.325. Slide ni pendek betul. Okay. Okay. Jangan ya. Okay, meaning that if I draw my waveform current IL, my IL current, so I got my minimum current here, and then it's ramped to maximum, and then go back to minimum and maximum. So my minimum is 0.25, my maximum is 1.75, right? And then at the center here is your IL average, which is 1 amperes. This one is actually will give you information of delta IL. Okay, between I max and I min, that is your IL. So sometimes the question give you delta IL, only give you this formula. This waveform. From this obtain delta IL. So if you don't understand the relationship between I max and I min, so you cannot solve that problem. So you need to know the relationship between the waveform and the circuits. Okay, from here, if the waveform here, you should know that I max minus I min is actually delta IL. Okay. Okay. Yeah. Yeah. So delta IL should be at around 1.5, right? 1.5. Okay. Last one, the output voltage ripple. I think next class we go for example 2. Last one, the output voltage ripple. So the output voltage ripple is you need to know that the charge inside the capacitor is always related to the capacitance values multiply with the voltage across the capacitor. Okay. So right now we know that the charge, the voltage across the capacitor is equals to your V out. Right. Kalau you refer to these circuits, right? This voltage capacitor is V out, right? Is your V out. So that's why here your Q is equal to C multiply V out. Okay. So any change of the capacitor, change of the charge is due to the change of the voltage across the capacitor. So this one is your ripple. So this one V out. Sama. Saya tak boleh tulis kat bawah sangat ni. Tak nampak. So delta, oh sorry. Okay, from that we can obtain your ripple voltage is equals to charge over C. So right now the capacitor is given, so but the charge is not given. So how to obtain the charge? We know that the current of the capacitance IC is actually like this, right? Which is the triangular, which is the base is T over 2 and the height is delta IL over 2. That is, you need to remember this. So this is your Q. Okay, so your Q is 1 over 2 multiply with the height, which is delta IL over 2. Delta IL you have already obtained, which is 1.5, right? So 1.5 over 2 is 0.75. Multiply with the half period. The frequency is 20 kilohertz. So you need to convert into time. Berapa? 20 kilohertz. And then bagi 2. Divide by 2. Because T over 2. Berapa dapat? 20 kilohertz convert. Ataupun 2 bagi 20K. 2 divide by 20K. Berapa? 25 microsecond. So this is your charge. So 1 over 2 multiply with 0.5 multiply with 25 microsecond. Berapa you punya kolom? Berapa? Charge. 9. micro column. Okay, so from that, you can get your delta V out. .375 micro over your capacitor is 100 microfarad. So compute that, berapa dapat? Berapa? Ya ke micro? 0.09. So your output voltage ripple. Okay. So this one output voltage ripple 0.09375 voltage V. Ini. Kalau saya, if I add one more question, ripple factors. Ripple factors is actually delta V out over your V out. Itu saja. Ripple factors. Delta V out you have already obtained 0.0739375 just over your V out which is 20 volt. You dapatlah you punya ripple factors. Berapa? 4 point? You kali dengan 100 atau apa? So multiply with 100, sorry. Multiply with 100. You should get. Berapa? 0.1875% Betul ke? Ha? Kosong point 468. 0.468%. So very small, meaning that the ripple is very small. Okay. So this is good, meaning that if your ripple is less than 1%, so meaning that your DC-DC converter is very good. Okay. So I think thank you. That's all from me today. So we meet again on Thursday. Sorry. Attendance. Scan QR. I give you in the WhatsApp group. You can scan.
Thank you, doctor.
Yeah. Okay, okay. Oh, sorry. Just to because your first test will be on this Saturday. Okay, please sit down. This Saturday, right? I think night time around maybe 9 p.m. I think. So the content or the content of the test one. So you have two parts. The first part is the true false. True or false. That one will be on your chapter 1. From meaning that the intro about the power electronics, the use of the switches, okay, type of switches, IGBT and so on, the rating and so on, snubbers, losses, okay, switching losses, conduction losses, so on. So I think all content in chapter 1 will be in the true or false statement. And you need, for example, if the answer is false, you need to give the reason. If the answer is true also, you need to give a reason. Online. Okay, so that is the first part. The second part, First part, there is no calculation, only true or false. And then the second part is the calculation. So the calculation is the half wave control, meaning that you are using SCR. Half wave rectifiers using SCR. The load is inductive load. Inductive load. And then inductive load, and then you should know on the usage of the freewheeling diodes, without freewheeling diodes. Okay, when you insert freewheeling diode, what happened? Okay, the firing angles, alpha, beta, all that. Okay, so I would like to remind you that I have already shared you on how to use your scientific calculators, right? To do integration. That one will be one question. For example, to calculate, I think maybe the current, for example, to calculate the current. So you can use your calculator to calculate the average current values. So please make sure that you familiar with the how to calculate using calculator. Okay. And I think maybe most of it, I think 60% will be sketching. You need to know how to sketch the waveforms, the relationship between the current, the voltage, and so on. Okay, and it will be online. So, but you need to turn on your camera. I know maybe you are trying to cooperate to each other. And we will always look at your mouth, okay? Kalau mulut tu bercakap, kita tahu. Sebab kadang you mute kan, tapi kita tahu you tengah bercakap dengan kawan you. Dia letak sini ada Bluetooth ke, kan? Okay? Sebab semua dah duduk dekat college kan? Itu masalahnya. Duduk kat college, seorang menghadap sini, seorang menghadap sini, tak nampak macam seolah-olah bilik lain. Okay, tapi kita itulah make sure that you are, orang kata apa, try to do as yang jujur as possible lah. Okay, jujur. Okay. Okay, I think that's from me. Yeah.
Doctor, is there any previous test you have?
Sorry?
Do you have any
Previous
previous? Yeah.
Okay, for the previous test, you can just Google. Because I see that when I Google SEE44 or SKE4433, you can have a lot of previous tests have been uploaded by previous students.
Okay. Thank you.
Okay. With the solution also you can get. Okay, that's all from me. Thank you very much.
Thank you, doctor.
Okay.